Hey everyone, and welcome. Today, we're going to trace a really fascinating career journey. It's the story of how a traditional mechanical engineer becomes this super high-tech specialist right at the front of what we call Industry 4.0. We're going to follow a real-world path, starting with physical blueprints and metal parts, and ending up at the cutting edge with digital twins. So, let's dive right in.
Okay, so before we start at the beginning, let's just jump to the destination. The big idea here is the digital twin. And yeah, it sounds like something straight out of a sci-fi movie, but it is very, very real. A digital twin is basically a living, breathing, virtual copy of a physical thing. Could be a car engine, a huge wind turbine, you name it. It's constantly fed real-time data from its physical buddy, which lets engineers test, predict, and optimize performance in the digital world before they ever lay a hand on an actual part. It's the ultimate bridge between atoms and bits.
So, how does somebody get to that point? Well, we've broken this journey down into 5 pretty clear stages. We'll kick things off with the engineering foundation, then move into mastering physical manufacturing, then we'll see this critical pivot towards data, watch how those skills come together to engineer a digital twin, and finally, look at what it all means as a blueprint for growth.
Our journey starts where all good engineering stories do, with the fundamentals. Before you can even think about building a digital world, you have to have a deep, deep understanding of the physical one.
The bedrock for this whole career, a bachelor's degree in mechanical engineering. This is where you learn the core principles of, physics, design, material science. It's the language you need to speak to understand how things are made, how they work, and just as importantly, why they break.
So with that solid foundation in place, the next step is to get your hands dirty. This phase is all about the real world of manufacturing. We're talking the world of atoms, super precise measurements, and quality control right there on the factory floor.
And you can see this clear progression right here. It starts back in 2018 as a quality engineer, learning the ropes of audits and quality systems. Then it evolves to handling more complex stuff, like welding processes. But the key moment here is in 2022, specializing as a CMM engineer. CMM stands for Coordinate Measuring Machine, which is basically a deep dive into the world of ultra-precise 3D measurement. And that becomes absolutely crucial later on.
And this wasn't just some occasional work. We're talking about inspecting over 150 different parts and assemblies every single month. That is a massive amount of hands-on experience, building this deep kind of intuitive feel for how physical components really behave. But all that experience wasn't just about volume. It was about getting smarter. By creating standard operating procedures, or SOPs, for inspections, they were able to speed up the whole process by 20%. That's a huge efficiency gain, and it just goes to show that truly understanding the physical world can directly boost the bottom line.
And, well, the results really speak for themselves. This mastery of the physical world led to achieving over 95% accuracy on the very first try during pre-production. Plus, for new product development, timelines were cut by 15 to 20%. So the main takeaway here is this: that deep, hard-won expertise in the physical world is exactly what makes the digital stuff so powerful later.
All right, now here's the turning point in our story. With a really deep understanding of the physical world locked in, the journey takes this deliberate, really crucial pivot towards the world of data, analytics, and code.
This is the million-dollar question, isn't it? How do you bridge that gap between inspecting a welded car part and writing a predictive algorithm? It doesn't just happen by accident, it happens through intentional, really focused upskilling. And this is exactly how that bridge was built. A whole new skill stack, constructed piece by piece, right on top of that engineering foundation. You can see a core data science certification, covering Python, AI, and machine learning. And then there are these specialized certs in tools like Polyworks for 3D scanning and Creo for design. This is literally the toolkit for translating the physical world into a digital one. And these new skills were immediately put to work. This wasn't just learning for the sake of learning. The first step was super practical, building a tool to automate the boring, tedious process of generating quality reports from all that raw CMM data. But the next leap was even bigger, using all that historical inspection data to build a machine learning model that could actually predict welding defects before they even happened. That is the moment engineering truly becomes data science. And that brings us to today, the culmination of this whole journey. This is where that deep expertise in physical manufacturing and the brand new skill set in data analytics all merge into one incredibly powerful cutting-edge role. To really get the impact here, just look at the old way versus the new way. Traditionally, if you wanted to benchmark a competitor's car, you had to physically buy it,
tear it down piece by piece, and manually measure everything. It's slow, unbelievably expensive, and you literally destroy the product. With the digital twin approach, you use high-res 3D scanners to create a perfect virtual model. You can analyze it without breaking anything, pull in all sorts of other engineering data, and reuse that digital asset forever. It's a complete game changer.
So, what's a day in this role actually look like? Well, it's a perfect hybrid. It involves hands-on 3D scanning. That's the physical skill. But it also involves reverse engineering those scans into digital models for what's called wave analysis, which is all about making the product better and more cost-effective. And then there's the data side, coordinating different teams and building these interactive dashboards in Power BI so everyone can see and track the project's data. It's the complete loop, from the physical world to the digital and right back again.
So what can we all take away from this? This career path isn't just some one-off story. It's really a blueprint for what the engineer of the future looks like. We're talking about a full-stack Industry 4.0 engineer.
This table just lays it all out perfectly. You've got these three connected pillars. First, core engineering, the fundamentals of design and quality. Second, precision metrology, the expertise in that ultra-precise 3D scanning. And third, data and analytics, the ability to code in Python and build machine learning models. When you combine all three of those, you get an engineer who can understand a physical product, capture it digitally, and then use that data to find powerful, game-changing insights. That's the whole stack.
And behind all this technical skill is a very specific mindset. This quote from the professional summary says it all. It's about being a dedicated, diligent, industrious technologist who's focused on finding innovative solutions, not just for the company, but for society and for nature too. It's a much bigger, mission-driven approach to engineering.
And so, we end with this question. We've seen how this fusion of physical and digital expertise is totally transforming the auto industry. But this blueprint, it could apply anywhere. Aerospace, energy, medicine, construction. So, the question to leave you with is this. What physical industry do you think is next on the list to be completely transformed by data? Thanks for joining us.